Hey, and welcome to the short stuff. The whole gang's here, even in spirit. So let's go. Stuff you should know.
Yeah, you put this one together. This is a good one. We're talking about the magnetic field and specifically the switching of Earth's magnetic pole. And I guess we should just start talking about what the magnetic field of the Earth is, right?
Yeah, you kind of can't really get past that one because apparently it seems to be fairly peculiar to Earth to have a really solid inner core made of, I think, iron and nickel. And that that is basically bathed in a bath of molten outer core. Mm-hmm. And because that molten outer core is constantly roiling and convecting and doing all sorts of crazy motions, it actually produces a dynamo effect where a magnetic field is generated. That inner core essentially becomes a giant bar magnet with a north pole and a south pole.
Yeah.
And that magnetic field radiates from the center of the Earth outward into outer space. And it does some pretty cool stuff. One, it prevents high energy particles that are bombarding Earth at all time from reaching Earth generally and killing us, just shooting right through your throat and out the other side. Right. So life can exist on Earth. And then less importantly, but more beautifully, it also creates the auroras.
And also why I wear a Kevlar turtleneck. Actually, not a dickie, really, because it gets warm in the summer.
Yeah, that's smart.
So you've got that bipolar core. We have the North Pole and the South Pole geographically. Like we know where those are. We've mapped those out. They're great. Everyone loves them. But they really have nothing to do with the actual magnetic poles of the Earth. Two different things. The Earth's poles, as we will see, they move around a lot because of that molten core is unstable, and it moves. That roiling sort of molten gunk you were talking about is weaker in some places. It's stronger in some places. And, you kind of likened it to a pot of water like bubbling and the bubbles like pop and fade away. Same thing is going on there that creates instability and sort of just movement.
Yeah. So suffice to say that the Earth's magnetic field is not constantly stable. It's constantly changing. And since some spots are weaker than other spots, that means the poles can actually move around. And they do. They wander about. There's these, it's called excursions. And they can move all over the place. And as a matter of fact, when what seems to be a threshold, they flip. And all of a sudden, the South Pole is at the geographical North Pole area, and the North Pole is down in Antarctica somewhere. And it happens, and we've just recently learned about this kind of thing.
Yeah, it's called polarity reversal. There's some disagreement among the scientific community about how often this happens, how quickly it happens. There was a study in 2020 from the Scripps Oceanographic Institute in San Diego. San Diego, right?
Yeah, the SD.
Well, it said SD. I didn't think it was South Dakota.
Definitely not.
Or Southern Durham, North Carolina.
It could have been that one. It's definitely not South Dakota, though. I'll tell you that.
Yeah. So they had a new model based on 100,000 years worth of data. And they said, actually, these poles are wandering like a lot. It's a real walkabout. They're wandering about 10 degrees a year. That is equal to the distance between Atlanta and Toronto, or for our Aussie friends, Brisbane and Melbourne. Or if you're in London, those are the three places that listen to us, basically.
Sure.
Canada, Australia, and the UK.
Yeah.
Or London and Prague. And that is about 10 times what scientists thought before this study came out.
Yeah, the pole can wander that far in a year. A year. You just, like, when you hear about this, you're like, okay, that's weird. I didn't know they could move. Maybe it just kind of gyrates a little bit. No, it can travel from Toronto to Atlanta in a year and back. And it wanders all over the place. It's not like it follows like a set line, because again, the molten inner or outer core, it's roiling. It looks probably a lot like the surface of the sun. And so all the little spots and weird like areas and everything, that's where the kind of like the magnetic poles actually travel, like down a Plinko set, essentially. But a sphere Plinko set, if you can wrap your mind around that kind of thing.
All right. Well, I'm going to wrap my mind around it, and we're going to take a break, and then I'm going to unwrap my mind right after this. right. So we were talking about this thing it's really hauling. These poles are moving around, and they can actually flip. And the last time that happened was about 42,000 years ago in what's called the La Champ, I guess. The La Champ Excursion. Great band name.
Yeah.
And this was the lava flow in France, of which it was named after because of the fossil record, I guess, that we discovered in the 1960s. And during this excursion, the North Pole went across North America, then said, all right, well, now I'm going to drop down into the Pacific, or through the Pacific, to Antarctica. And then I'm the North Pole, by the way, and I'm going to stay there in Antarctica for about 400 years, and then I'm going to go back up through the Indian Ocean to the actual geographical North Pole.
Yeah, roughly that area. Back to generally where the magnetic North Pole typically is, right?
Yeah.
That's really fast. 400 years on a geological time scale is like, a blink is too slow as a description or analogy. And so the La Champ excursion seems to have had some pretty significant effects on the planet. That 42,000 years ago coincides with a bunch of weird stuff that happened on Earth. There was a lot of glaciers that expanded in all sorts of surprising places. The wind patterns changed globally. The megafauna, a lot of megafauna species disappeared from the fossil records, and so too did the Neanderthals.
That's right.
It was a really, really significant period of like surprising and kind of dismal activity in Earth's history. And they have traced this to basically a weakening of the magnetic field, that it's probable the magnetic field became very weak and that allowed the poles to flip very quickly. And that it wasn't necessarily the poles flipping that caused all of this weird stuff to happen, but that the magnetic field being weakened probably also let this weird stuff happening. So the reversal of polarity was a symptom, just like, say, the disappearance of the Neanderthals was, or the change in wind patterns were. They were all symptoms of this weakened magnetic field around Earth.
Yeah, you talked about it, sort of acting like a force field against that particle bombardment. That probably weakened it enough that they were bombarded. The ozone layer was damaged. A lot of UV light is just baking the Earth. And it was just bad enough where scientists obviously are like, well, when is this going to happen again? Because we're in store for something pretty rough. And what they've kind of come out with was, we're not sure exactly when it's going to happen again, because you can't look back. I think you mentioned earlier it doesn't necessarily happen in a pattern that you can count on.
Yeah, it doesn't seem to.
Yeah, so they can't say like, all right, well, here's when it's going to happen again. But they do think this was the La Champ excursion was a sort of a rare, fast thing. And if it does happen again, it'll probably be over the order of thousands of years.
Yeah.
And it's not going to be the kind of thing like most of the other times it happened. It was over a much slower time period. The La Champ was just so fast, it wrecked everything. And it probably wouldn't be that bad if it happened again, because it would be on a much slower, thousands and thousands of years timeline.
Yeah, I mean, tens of thousands of years versus hundreds of years. That's pretty significant as far as differences go, right? And if this sounds kind of like if it rings a bell, we talked a little bit about this in the plate tectonics episode, where like the magnetic striping at the bottom of the sea is basically lava flows recording reversals in polarity of Earth's poles. This is very much what we're talking about. So because they think it happens over, tens of thousands of years, and if you look back in the fossil record at other times that coincide with polarity reversals, there doesn't seem to have been anywhere near the kind of catastrophic events that came from the La Champ excursion. They're not particularly worried about it, but we do know that if it did happen on like a normal slow time scale, we still have to adapt because a lot of our technology relies on a stable magnetic field.
Yeah, I mean, they have to take that stuff into account. Like when they look at the fossil record, maybe not much of anything happened because they weren't using satellites and they, didn't have things floating around in space. But there's an area called the South Atlantic Anomaly between South America and South Africa where there's a weaker magnetic field than elsewhere on Earth. And when satellites and stuff go through there and spacecraft, there are issues.
They're like, can you hear me?
Yeah, exactly.
Are you still there?
And they say, in space, no one can hear you scream. Name that movie.
Spaceballs.
Exactly. So that's an example of like what can happen with just a somewhat weaker magnetic field. So they would have to account for that stuff ahead of time, know it's coming, and account for it. I think there would be some economic impact.
Yeah,
but
for sure.
I mean, I think who was it? The Cambridge Center for Risk Studies said that it could be like a $6 to $42 billion cost for the United States, which honestly, that's chump change when you look at, budgets of the United States.
Buddy, that's a day.
Yeah.
A day.
So it's not like, I mean, that's a lot of money, obviously, but it's not like that would wreck the American economy or anything.
It depends on how long it went on for,
Well, yeah, I guess so.
I mean, if they didn't get up and running within a few hours, that could be, it could add up.
It could add up.
Speaking of knowing it's coming, I want to go ahead and stem the tide of emails. I know that Chuck was talking about Alien, by the way, everyone.
How could Josh say Spaceballs?
One other thing, Chuck, because the disappearance of the Neanderthals coincides with the weakening of the magnetosphere and probably bombardment of UV radiation and ions, you may be right that the Neanderthals really did melt. You might be onto something, man.
That's an old one.
You got anything else?
I got nothing else, JM.
Well, then Short Stuff is out.
Stuff You Should Know is a production of iHeartRadio. For more podcasts from iHeartRadio, visit the iHeartRadio app, Apple Podcasts, or wherever you listen to your favorite shows.